Hello everyone. In this particular video, we will talk about mathematical Olympiads and other opportunities like summer camps, entrances for students in class 9 to 12. We will talk about the opportunities, we will discuss the books that you should follow, and finally, we'll also talk about learning strategy or preparation strategy. My name is Ashwini Dashgupta. I'm a faculty for Mathematical Olympiads and researcher at Cheenta.com. You can find more information in the link in the description, particularly book lists and summer camp details and other things. So let's first talk about the opportunities. At this level, from classes 9 to 12 or grades 9 to 12, the first level of the real mathematical Olympiads begins. In India, it's called IOQM. In United States, it's called the AMC, the American Math Competition 10 and 12. And in other countries, they have other names. The first levels of mathematical Olympiads are usually either multiple choices, like AMC 10 and 12, or they are number type. So the answer is a number, like in IOQM for the last year. But apart from IOQM, AMC 10 and 12, which are the mathematical Olympiads, if you have qualified for this, then you can go to the next levels. For US, it is AMI and USMO. For India, it's Indian National Math Olympiad. For United Kingdom, it's called BMO, and for Singapore, it's called SMO. So there are different names again for different national level math Olympiads. All of them are very similar in nature. Usually they have 5 to 6 problems which are subjective in nature. That is, you have to write down detailed proofs, and they are usually 4 to 8 hours long depending on which country you are in. So first level IOQM, AMC 10 and 12, then comes AMI, USMO, INMO, all of these things. By the way, Indians and other national student nationalities are also eligible for taking AMC 10 and 12. Particularly if you are interested in pursuing higher education in United States, then it's a good idea to take the AMC 10 and 12 and AMI. So these are the mathematical contests which are like directly out there. Then comes the sort of the offbeat contests. I will mention three of them. The Sharagin Geometry Olympiad, it's a very prestigious contest conducted from Russia. Cheenta collaborated with the organizing committee from Moscow last year to conduct the Indian version of the Sharagin Geometry Olympiad. Then comes EGMO, European Girls Mathematical Olympiad. That's also a very nice contest. And there is another one which I really like, which is not that popular in India, but it's very, very powerful. It's called Tournament of Towns. So these three contests, if you need specific information about them, you can ask if you are an internal student of Cheenta, you can ask the admin at your personalized WhatsApp group and they will definitely help you. So the regular Olympiads and the offbeat ones. These are the contests that you should be focusing on. Now comes the entrances. Because you are in high school, the next step is to go to a college or university. And I will talk about three entrances which are mathematical in nature and which will take you to some of the best places in India and in UK. So in India, the Indian Statistical Institute's BStat BMath entrance, that's an excellent examination to take. About 200 students get selected in the first round, I think, from the entire country. So it's a very challenging contest. It has an objective section, a subjective section, and it requires a lot of work, preparation. Some of it overlaps with the Math Olympiad curriculum actually. Then is the CMI, the Chennai Mathematical Institute's entrance, CMI BSc Math entrance. CMI has excellent programs in mathematics, and they allow a second major in physics or computer science. Their questions are also, there is some overlap with the Mathematical Olympiad curriculum. So when you are preparing for Mathematical Olympiads, you are automatically preparing for these entrances as well. And outside India, I would suggest STEP. STEP is organized by Cambridge University, and it's useful for admission in universities in United Kingdom. So the questions are also, there is some overlap with the Olympiad curriculum. These are the contests and entrances that you should be focusing on. There is a third type of opportunity which are called summer camps. Cheenta itself conducts a summer camp on research in mathematics, but there are other summer camps which are conducted offline. Cheenta summer camp is online. There are offline summer camps conducted by different universities like Stanford, Carnegie Mellon University. In India, there is Promise Foundation, and TIFR also conducts one. So instead of giving you the specific names of the summer camps, I will indicate a link in the description which contains that information, so you can look into it. Summer camps are a good place to meet professors and researchers from advanced mathematical research and build relationships, learn new things. And if you are planning to apply for a university in a different country like US or UK, maybe you can seek out their recommendation letters later. So it's a good thing to take summer camps. So we talked about three types of opportunities: contests, entrances, summer camps. Now let's go into the preparation strategy. Now, the reason so many Cheenta students are successful in IOQM or AMC 10 and 12 or INMO is because the structure of our preparation program. There are three, usually, this is not true for every student. There are different time zones, which makes things a little difficult for some students. But usually what happens is there are three classes: concept class, homework class, and doubt clearing class. And then there are 5 problem-solving classes in addition to it. So total 8 classes in a week. This is the amount of work that is required, like it's the bare minimum requirement to be successful in mathematical contests. We think so, and it has worked really nicely. 6 students from Cheenta got through IOQM, 12 of them got through AMC 10 and 12, and 4 of them got through Indian National Math Olympiad just the last year. So we think that this method is working. So there are two components of this: concept and problem. It's very important to build a solid foundation of the concept. I often say this as fundamental principle. So instead of using a lot of formulas and a lot of theorems, if you can solve a problem using fundamental principles, that's even better. It tells the examiner, it tells you that your grasp on the basics is really strong. So build a strong conceptual foundation, but parallelly make sure that you are exposed to a lot of new problems every day. It's not one day you do it and then you don't. You have to do it every day. The thing about problem solving is that even if you know all the theorems and formulas, you might not be able to solve a problem. And that happens in the beginning when you are starting out with the program. That is okay. It happens with everyone. What you have to do is you have to observe the problem. You have to sort of try on your own, think a little bit. Even if you don't know, even if you think you don't know all the tools, you can think with whatever tools you already know. That's all right. Some of the problems may get unlocked even with very little tools. That unlocking procedure has to happen in your mind. So what I have seen the successful candidates to do is they sit at the corner of a room, they make small sketches of diagrams, they try out different scenarios, they do casework, all of these things. They are playing with the problem. And even then, the problem may not get unlocked. So you have to give time to the problem. This is how problem solving works. So for Cheenta students, they are facing 5 days a week problem solving, which gives them a lot of experience with problems, a lot of experience. So you have to allocate, if you're even if you're not in Cheenta, you have to allocate at least 1 or 2 hours every day to solving and thinking about problems. That's very, very important. So two parts, conceptual foundation and problem solving. Both of them should go hand in hand. So how to do that, how to select resources so that you can do both of these things. So there comes the books. So let me talk about the books, which is the third segment of this discussion. So first I will suggest a couple of very basic books. These two books you should do cover to cover. The first one is Challenges and Thrills of Pre-College Mathematics. This is by Pranisachar and Krishnamurthy. It's an excellent book, especially the geometry section is really solid. So you should definitely complete this book cover to cover. And then there is another book, An Excursion in Mathematics by Modak, and there are other authors as well. It's a thin book, it's very terse, but it has all the necessary beginners material. So in Cheenta, there is in IOQM and AMC 10 and 12, it's a 2-year program. First year is usually called level 6. The second year is called level 8. In the first year, we usually suggest the students to complete these two books from cover to cover so that they have a very solid foundation on which they can build and learn new things. Now, once you are done with these two books, then you can specialize on different areas of mathematics. For example, you should know some trigonometry certainly. For trigonometry, I'll suggest two books. The first one is called Trigonometry. It's written by Gelfand and Saul. It's an excellent book for building your concepts. And for problem solving, there is a book called 103 Problems in Trigonometry by T2 Andreescu. It's an excellent collection of geometry problems which can be solved and should be solved using trigonometry as explored by Andreescu. Then comes, after trigonometry comes geometry, the other part of geometry. So there is an excellent book, Euclidean Geometry for in Mathematical Olympiads by Ivan Shen. Ivan Shen is an excellent trainer and excellent writer for Mathematical Olympiads. He has been writing and coaching students for a long time. And this book compiles all his insights, his experiences in solving Olympiad standard problems. Excellent book. So that there goes geometry. Now comes combinatorics. For combinatorics, we suggest Principles and Techniques in Combinatorics by Xuan Sean Shen and Ko King Mei. Principles and Techniques in Combinatorics is a very comprehensive book. There are many other good titles, but we like this one very much. And more importantly, it has a lot of problems derived from Olympiads in the example sections as well. So try that. After combinatorics and geometry comes number theory. In number theory, the main book that I would suggest is by T2 Andreescu and Dorin Andrica. This is called Number Theory, Structures, Examples, and Problems. Of course, there are many other good books. One of them is Elementary Number Theory by David Burton for fundamentals and concept building. But this book is more problem driven in nature, and you should definitely look into it. The final thing is algebra. So in algebra, there are three or four separate portions: complex numbers, functional equations, inequalities, and polynomials. For complex numbers, I would suggest Complex Numbers from A to Z by Doreen Andrica and Tito Andrescu. For functional equation, there is a very nice book by Venkat Shala, whose title is Functional Equation. For polynomials, there is a book by Burbew titled Polynomials. And for inequalities, I would suggest Secrets in Inequalities by Pham Kim Hung. So all of these books, the name of all of these books I have put in the description section so that you can use them and learn from them. The main idea is to keep problem solving and theory building hand in hand. That's the main thing. So thank you for watching this video. If you have your own ideas and comments, please let me know and in the comment section, and I'll see you in the next video. Thank you.